Hello and welcome to this video in discrete structures. In a video prior to this, I showed you how to set up the input columns for truth tables. Now I'm going to show you some examples of using truth tables to find the result of a compound statement. So here this is actually three questions here. We're asked to find not P and Q. It is false that P and Q, and it is false that P or Q. So each of these, they're basically three separate problems. There's problem A, there's problem B, and there's problem C. We have two statements in each of these, and they're all P and Q. So two statements, 2 to the second power will give me 4 rows. Here's my 4 rows. The first, so you write P then Q, it goes in alphabetical order, left to right. The 4 rows, half is 2, so 2 zeros, then 2 ones. And then I just did 2 zeros, so here I do 1 0 and 1 1, 1 0 1 1, repeat it until I'm done. Now, here's the new part. How do I go about breaking up my problems to do them? I'm actually going to do 3 problems here. These are the 3 problems. So I'm going to look first at problem A. For problem A, I see that I'm asked to find not P and not Q. Well, I don't really like to keep a lot of things in my head at once. I'd rather find not P and then find not Q and then join them with the and. I know the and, if they're both true, it'll be true. If either one of them is 0, I'm going to get 0. If they're both 1s, I get a 1. But I don't know if not P is a 1 or not Q is a 1. I'm going to make a column for not P. Here's my column for not P. That's the not sign right there. So what I do here is I look over at column P, and here I see in the first row I have a 0. So the opposite of the 0, the negation of a 0, is a 1. In the second row I have a 0. The negation of that 0 is also a 1. In the third row I have a 1, so I get a 0. In the fourth row I have a 1 for P, so not P is a 0. I'm going to make a column for not Q. I'm going to make that a different color. Since I have colors, I might as well use them. There we go. Make that a lovely red. Not Q. So this time I'm doing the same thing, only I'm looking at the values of Q here. In the first row, Q is 0. So in the first row here, not Q will have to be the opposite. It'll have to be a 1. Second row, Q is 1. So this second row, not Q is a 0. Q is a 0. Not Q is a 1 in the third row. And in the fourth row, Q is a 1. So these are rows going across and columns going up and down. That will be helpful to remember when we do matrices. So I have 1 0 1 0 is not Q. So these are the 2 columns I'm combining with an and. And in some books I've worked with, they actually do this, and that you write the answer in the middle. You can do that. You could write the answer for each of these ands here, or I'm just going to make another column. This is not P and, oh, I didn't write the P, not Q. So I'm just, whatever's in these 2 columns, I'm anding them together, a 1 into 1. And works kind of like multiplying. 1 times 1 is 1. I get a 1. Anytime I have a 0, my and is automatically a 0. And the thing about logic is you're only ever really working with 2 things, a left side of the symbol and a right side. On the left side, I have the not P. On the right side, I have the not Q. The value on the left and the value on the right are combined with the connective and. The rule for combining the connective and is the only way you get a 1 is if both values were 1. Both statements had to be true if you join them with an and for the resulting compound statement to be true. So this right here is my answer to part A, this column. And this is why it's important that we put our P's and Q's in the correct order, both left to right correct, alphabetical order, and starting with 2 zeros, then 2 1s, 0 1 0 1. Because if I want to compare this to another one of these, I have to have used the same inputs. Now to do B, I could write a new truth table. I could write out another set of P, Q, 0 0 1 1 0 1 0 1. There's really no need to, though. This right here can serve as my inputs for part B as well. Let me go grab a different pen so it's easier to see. Try some orange here. So this one, what I see is I don't need not P, I don't need not Q, but I'm doing the opposite of P and Q. It would be helpful as an in-between step if I wrote out the truth table for P and Q. So P is here, again, in the first row. So this one will be a 0, and a 0. So that's going to be a 0. In the second row, let's see, I'm doing an and, so as soon as I see a 0, I get a 0. Third row, Q is 0, so that makes that 0. This is an and. If it were an or, it would have gone 0, 1, 1. All you need is 1, 1 to show up for or to work. It's like and is kind of like multiplying, and or is kind of like adding, only if you add 1, 1 and get a 2, you still write a 1. 1 times 1 is 1. So the and, this will be P and Q. So this is what's inside those parentheses. Now, I want to do not P and Q. I'm going to do the opposite. I already found this piece. I already found that. It's right here. So I just look to the column to the left and write the opposite. 1, 1, 1, 0. So this is part B. And for part C, you've probably lost track of the problem here. It's this not. It's again, it's an or on the inside this time. Oh, I don't like that pen. That pen's no good. It's like it's out of ink. Let me turn this one to a green. There we go. So for this one here, first I'm going to write P or Q. And look at that. I had exactly the right number of columns. I did not actually plan that. So P or Q, I'm still going back here to look for P or Q. That's a reason you might want to make it separate. It's easier sometimes just for visually to see. But P or Q, 0 or 0 is 0. Now for the or, it means is either one of them 0 or both of them. It's not an exclusive or. If they're both a 1, you say the or is a 1. So the or goes like this. 0 or 0 is wrong. You can think of it like this. If I promised you I would wash your car and fill the tank with gas, if I didn't wash the car, which was P, and I didn't fill the tank with gas, you'd say, you're a liar. But if I did both, you wouldn't complain that I was lying. So as long as I do one or the other, when I say or, you expect I will do one or the other. But if I do both, that's okay too. In the case of this or, this is called an inclusive or. We're not going to get too tangled up in those details. But so what I've done here is just the inside part. I've done what's in the parentheses. Just like algebra, you work from the inside out. So now the last column, which will give me my answer to C, will be the opposite of. It is false that P or Q. So this tells me it is true. This is what happens when P or Q is, if P or Q is in effect. But if the opposite is in effect, it's P or Q it's false that P or Q. Then you just literally, zeros become ones, ones become zeros. So that, I picked these examples for a couple reasons. One is you can see that it's helpful to make different in-between steps, order of operations. Order of operations says you do in parentheses first, then you do negation. So here in problem A, I did the negations first, and I made a column for each of them. So I don't have to keep in my head, oh, P was 0, so not P is 1, Q is 0, so not Q is 1. I don't have to put it in my head, I can write it down. And then the final, so the green and the Q are my in-between, and the red are my in-between steps. And then when I'm finally getting to my answer, I'm still just looking at a 1 and a 1. Oh, a 1 and a 1 is a 1. I don't have to think in multiple steps. So for part B, I would do the P and Q first and then take its opposite. I would not try to figure out what P and Q was and then do the opposite all in one step. Now, some of you have better, younger minds than I do and could have done that. Don't rely on that, though. Don't make it more difficult by having to remember a lot of stuff in your working memory. What I want to point out is the solutions to these. So this not P and not Q came out to be 1, 0, 0, 0. And it turns out that's the same. It's not the same as taking the not outside. So I did not P and Q. Notice it's not like I can just take the negative out. But what I can do is if I take the negation out and I switch the sign, you can see that not P and not Q is equivalent to not P or Q. So if I want to write not P or Q, I can't write not P or not Q. We use 3 lines to show equivalent. It's not really equal like algebra. It's 3 lines for equivalence. But I can do not P, and I can do not Q. But just like distributing a negative in front of a binomial, you have to change the sign. You change it to an or. It also works if I start with an and. Sorry, that was an or. If I start with an and, I can write not P and write not Q, but then I have to change my and to an or. This is something called De Morgan's law. It is how you can write equivalent expressions when you have the negation of a parentheses, or if you want to simplify by pulling the negation out there. It works in multiple ways. There'll be other videos on De Morgan's law, but I just wanted to point that out. So we would say that A and C are equivalent. We'd say that statements A and statement C are equivalent because they produce the same final column in the truth table. That's why it's important to put these inputs in the same order all the time so you can compare. All right, I have another one to do. This video is probably going to be a little longer than you want it to be. This one is 3 letters. I have a P, a Q, and an R. And as you can see, I've written 1, 2, 3, 4, 5, 6, 7, 8 rows. I've put P, Q, R in alphabetical order. Half of 8 is 4, so 4 zeros, then 4 ones, 2 zeros, 2 ones, 2 zeros, 2 ones, and I've set up my inputs that way. You set them up that way every time. Now this one has a bunch of, this is the if and only if biconditional. And as a reminder, for the biconditional statement, what you're looking for is for them to match. So if I have a 1 and a 1, I should start with 0 and 0. I'll do it this way. 0, then 0 is a 1. 0, then 1. They do not match. You're saying if and only if. Today is Tuesday, if and only if tomorrow is Wednesday. It's never going to be the case that today is Tuesday and tomorrow is Thursday, is what I'm saying there. So, if they match, basically the biconditional says that whatever happens to one of these variables, the other always does the same thing. And so you say, and you get a 0 if that's not the case. So this would be 1 if and only if 0. That will also be a 0. So that's how the biconditional works. The conditional is trickier. Students always mess this one up. What you have to remember in the conditional, the if-then, because the order of the if-then, this is the only one the order matters. So the if-then is like a promise. I say, let's say statement P is, if you get an A on the final, and statement Q is, you get an A on the course. And I'm not saying that, but if I had said that to you, if you get an A in the final exam, then you will get an A in the class. So 1 here means you got an A in the final, but this means you didn't get an A in the class. So I broke a promise. Now, if you don't get an A in the final, but you do get an A in the class, you're not mad at me. So that's so this one, it turns out, is fine. So you can only put a false or a 0 in this case if you can prove I'm lying. If you don't get an A in the final and you don't get an A in the class, I didn't necessarily break a promise. You have to give me the benefit of the doubt. So that's a 1, that's a 1. But if the first thing happens, if the first thing's a 1 and the second thing is not, then that's the only case where you get a 0. It's almost easier to reason this one out with trues and falses. But 1 than a 1 is a 1. So I made a promise and I kept it. Here, number 1 means I made a promise, and 0 means I didn't keep it. 0 means I didn't make a promise, but I did something nice anyway. Nobody cares about that. So this is the output for your P, if P, then Q. So in this one, I'm going to start. Now, there's a couple things going on here. I've got to apply this if and only if, which I'm showing you. And I've got to keep track of my rows, P, my columns. I'm doing P and R, not P and Q here. So do P and R match is the question. And they do match, so that's a 1. If there's a double arrow, you're going to put a 1 when the two variables match. Here, this one is going to be a 0. And you can see P and R are not, they're going to match there. They're not going to match here. They're not going to match here. I go to 1, 0, but then they'll match, not match, and match. So here I get a 1 and 0, but this last one is 1, 1. Then I'm going to do the negation of P, then R. So I'm just negating what I just wrote. I just literally look at the column next to it and write the opposite. So that's this piece here. I've done that in green. Now I'm going to do the other piece. The other piece, I need a not Q. So I'm going to do this piece here. To get a not Q, I have to look at the column for Q. I have to look right here. And I can see it's 2 zeros and 2 1s. I'm going to do the opposite. So I'm going to do 2 1s, 2 zeros. You don't have to go row by row if you know what the pattern is. I'm just doing the opposite of the pattern for Q, for not Q. And then I'm going to do not Q or P. I'm sorry. Yeah, that's or not Q or P. So if either this row or this row has a 1 in it, the row and the column that I put in the orange arrow there, the column for P, the column for Q. In row 1, Q, not Q, has a 1. Actually, it's an or, so as soon as I can see, as soon as not Q is a 1, I know I'm going to have a 1. It doesn't really matter what P is. If P is a 1, I get a 1. If P is a 0, I get a 1. Now, when the rows where Q, not Q is 0, I have to look at P. Well, I can also remember that, so P is a 0 in the third row and a 0 there, so the or is a 0. Looking at this 0 here and this 0 here, I get another 0. But then the rest of the P's at the bottom here are 1, so I also get 1s there. So that's this piece here. Now I'm going to label. This is going to be, let me get it. I'm going to call this column A and call this column B because it's going to be easier to fit in up here. Column A was this whole thing here. Column B is this whole thing here. And I'm joining them with an if-then. So I'm going to do A, if-then B. And they happen to be in order from left to right. If they're not, sometimes I rewrite it. So I rewrite column A and then write column B, because the order is important. So if I jot down this set of facts here for the if-then, anytime the column on the left, which in our case is A, anytime the variable on the left is a 0, anytime the variable on the left is a 0, I can say I get a 1. It doesn't matter. If the left side is 0, you by default go to a 1. So wherever column A is a 0, which would be here, and call it row 1, row 3, row 6, and row 8. I can immediately fill in a 1 because it doesn't matter what's in column B. If column A is a 0 on the if-then, if the left side is 0, the output is always a 1. Now, I have to go back and look at the rest of them. So the rest of them, I have column A is a 1 and column B is a 1. That's what I would expect. So the rest of these, so I made a promise and I kept it. This is the 1, 1. It's this case here. So these are like your arithmetic facts. There's a 1. Now this one here, I go to column A, there's a 1. But in column B, there's a 0. I made a promise and I didn't keep it. A 1 on the left and a 0 on the right creates a 0 for the if-then. And then a 1 on the left and a 1 on the right creates another 1. A 1 on the left and a 1 on the right. I'm looking at this and this. That creates another 1. And this is my final answer, this row here. Okay, so I had to take care of the left side. I had to figure that out in steps. Then I had to figure out the right side in steps. I have to know my and, my or, my if, then, my if and only if, or have them written down someplace convenient. Recognize that the if then is the only one where order matters. If there's a 0 on the left of an if then, so if P equals 0, it is always true that P, if P then Q, is going to equal 1. Because it doesn't, if you didn't make a promise, it doesn't matter whether you kept it or not. You could still be an honest person. That's kind of the analogy I use. All right, I hope you found this helpful. I think that's the last example I have. You do have one in your homework where you have to do 16 rows. So you're going to do P, Q, R, S, or whatever the letters are in alphabetical order. 8 zeros, 8 ones. There's only one of those. You can type them out. You can throw it in a spreadsheet. Some people like to type their homework for these because they set up the inputs. They just set this up once for 2, 4, or 8 in a table, and and just copy and paste and then fill in the tables as they need. And I hope this is helpful, and I will see you in class.